In this lecture, we will discuss about elemental variations of various coordinates and their significance. For understanding of coordinate system, for understanding of various calculations in physics, for understanding mathematical physics, this lecture will be truly helpful. First, what we mean by element. Element means small portion, and how much small? As small as we please. Or in other words, we can say it is infinitesimally small. So there is no limit to the smallness. If you think an amount is small for you, your friend might think that it can be divided into two parts and you can go to a smaller length. So if say 0.01 appears to be a small number to someone, then someone else might think that 0.01 divided by 1000 is much smaller than this number. And someone might be there who might divide this number again by say 1 lakh to arrive at a much smaller number. So this is exactly what we mean when we say an element of something. But one thing has to be kept in mind. You can make the thing, the portion, as small as you please, but you cannot make it 0, because if it is 0, then the thing is not there, and therefore the entire idea is lost at once. So in a nutshell, the element should be there, and so it is not equal to 0, but it is as close as possible to 0. So this is a limiting idea, and this is what we mean by an element. We will take up first what we mean by line element. So line element is a small portion of a line, and we'll show it in diagram. Let us consider Cartesian coordinate system. This is x, this is y, and this is z. A small portion along x is this one, which is dx. A small portion along y is dy, and a small portion along z is dz. So we have dx, we have dy, and we have dz. Let me mention once again that dx, dy, dz and so on are infinitesimally small quantities. And they are as small as we please, but not equal to 0. What do we mean by delta x, delta y, delta z, etc.? These are finite quantities. We often denote these quantities also by the symbol delta x, delta y, delta z, but never denote them by del x or del y or del z. They have no meaning at all. Del del x, del y, del z has a meaning, but del x, del y, del z used separately doesn't make any sense. Another important thing is that this set of quantities which are infinitely small or infinitesimally small are immeasurably small. So you cannot measure them because there is no limit to smallness and hence we cannot measure it. But these quantities can be measured. They are measurable quantities and hence they are finite quantities. And these are infinitely small. So they are measurable quantities. We have thus denoted the line elements corresponding to the Cartesian coordinate system. We will now denote the line element of spherical polar coordinate system. In spherical polar coordinate system, the coordinates are r, theta and phi. So this is x, y, z, this is the origin, this is r cap, and a small element here is dr. So dr is the small element along r cap. This is r and this is dr. So the line element corresponding to the radial coordinate is dr. Let us redraw it. So this angle is theta and this distance is r. Now suppose theta increases by a small amount d theta so that it comes here. Hence an arc is described. So this is d theta, this is r. So this arc element is r d theta. Now we will increase phi by a very small amount d phi and investigate the line element associated with phi. So this is x, this is y and this is z. This is the origin. This is r. This is theta, the polar angle. This is the polar axis. Let us drop a projection. Let us join it. So this is phi, measured from the x-axis in the anticlockwise sense. So this is in fact phi. Let us increase phi by a very small amount, say d phi. And this distance is rho. Now if we increase phi by d phi, so that this rho rotates by d phi and this tip comes here. So this angle is d phi. Obviously an arc is traced here and the length of this arc element is rho d phi. So it is rho d phi and use the relation that rho is r sine theta. So this arc element in spherical polar coordinate system is r sine theta d phi. So we have identified or we have shown the length elements associated with r, theta and phi, dr, r d theta and r sine theta d phi. Next, the line elements in cylindrical polar coordinate system. x-axis, y-axis, z-axis. This is the origin and this is r, and the distance of this point from the z-axis is rho. A small element of this line, say this distance, is d rho. Cylindrical polar coordinate system consists of rho phi z. We have got d rho, and the length element corresponding to phi was shown. So this is rho, this is phi, so this is phi, and if this point rotates, in other words, if we increase this angle further by say d phi, then this rho will trace an arc. The length of this arc is rho d phi. So rho d phi is the length element corresponding to phi in the cylindrical polar coordinate system. And the easiest one to show is the length element corresponding to z, which is this one. Let us make a gist of what we did. Line elements in various coordinate systems. In xyz system, it was dx, dy and dz. Dx, dy and dz. In the r theta phi system, the line elements were dr, r d theta and r sin theta d phi. This is dr, this is r d theta, and this is r sin theta d phi. In cylindrical polar coordinate system, rho phi z, the line elements are d rho, rho d phi and dz. This is d rho, this is rho d phi and this is dz. We can consider these line elements as vector quantities by attaching unit vectors which are tangents to these line elements. And this is the coordinate system, x-axis, y-axis, z-axis. This is the origin. The length elements are, this is along x-axis, this is along y-axis and this is along z-axis. And the directions are, this is x cap dx, this is y cap dy and this is z cap dz. So the length elements which we represent by vector dr are x cap dx, or it can be y cap dy, or it can be z cap dz in Cartesian coordinate system. So this is r cap. The line element along r cap is this length to which we can attach a direction, and therefore it becomes r cap dr. Now this angle is theta, and suppose theta increases, and this elemental angle is d theta, and this distance is r. So clearly this point comes here, so an arc is described, and this arc element is r d theta. This is r, it is r d theta, and we can draw a tangent to it, which is theta hat, the direction of increase of theta. So the length element here is r d theta is the magnitude and theta cap is the direction. So it is theta hat r d theta. So the length elements are r cap dr and theta cap r d theta. This is rho, this angle is phi, and suppose phi increases by an amount d phi. So this is d phi. So an arc is traced, which has been shown here, and the tangent to it is phi hat in the xy plane. We can also show it in the xy plane. So this angle is phi, this angle being d phi. So the arc element here is rho d phi, and let us attach phi cap to it. Now rho is r sine theta into d phi. This is the arc element in spherical polar coordinate system. Let us write them at one place. So dr can be r cap dr, it can be theta cap r d theta, or it can be phi cap r sine theta d phi. Now come to cylindrical polar coordinate system. These are the axes, this is the origin. This direction is rho hat. The length element along this rho hat is d rho, to which we can attach the direction rho cap, and therefore the length element is rho cap d rho. So this is one length element in cylindrical polar coordinate system. This angle is phi, this distance is rho, and suppose we make an increment of phi by an amount d phi. So this tip comes here in the xy plane. So this is d phi. The things are happening in the xy plane. An arc is described here in the xy plane, and the direction is phi hat. So the length of this arc element is rho d phi, and we can attach the unit vector phi cap. So this is a length element in the cylindrical polar coordinate system, and elemental length along z axis is here. To it we can attach a direction z hat to get z cap dz. So in cylindrical polar coordinate system, the length elements are rho cap d rho, phi cap rho d phi, and z cap dz. Having written down and drawn the line element, It is now easy to extend the idea further. With the help of two lengths, we can build a surface, which means if we multiply these two line elements, we get a surface element. And similarly, we can multiply these two line elements to build another surface element. And similarly, dy dz will result in the third surface element. So in a similar way, in each of the coordinate systems, we can build surface elements, which we will do now. And the surface elements or the area elements are vector quantities. So we have to also indicate their directions. Surface element is a small portion of a surface, and as mentioned earlier, small means infinitely small. Small means infinitesimally small as we please. First, in Cartesian system, the length elements are dx, dy and dz. Let us build the surface elements. So this is dx and this is dz. And we can complete the surface element. So what we get is dx dz, because this is dx and this is dz. This is dz and this is dy, and we can complete the surface. So this is dy, this is dz. So this surface element is dy dz and this is dx dz. This is dx and this is dy. So this is dx and this is dy. So the surface element is dx dy. Attaching unit vector is easy in these cases because these are flat surfaces. So here we end up with flat surfaces, which are dx dy, dy dz and dz dx. And we can attach the unit vectors. Dx dy, it will be z hat. In case of dy dz, it will be x hat. And for dz dx, it will be y hat. Of course, tracing is important. It could as well be of negative sign if traced in the opposite sense. In spherical polar coordinate system, that is in r theta phi system, the length elements were dr, r d theta and r sin theta d phi. This is r, this is theta, so this is dr, a small increment in r, and suppose theta increments by an amount d theta, so an arc is traced. So this is d theta, and generate the surface element. So surface element has been generated, which is r d theta into dr. That is the product of the first two length elements. This is r and this is rho. This angle is theta and this angle is phi. Let us draw these two arc elements or length elements. So this angle is d phi and this angle is d theta. So we have got this length element as well as this length element, and we can complete them. This is r d theta and this one is rho d phi, which is equal to r sine theta d phi. And therefore this area will be the product of these two length elements, which is r d theta into r sine theta d phi. We now build a surface element by taking the product of dr and r sine theta d phi. So this is rho, this is r, this is theta, and this is phi. Now let us show this rho d phi. So this is rho d phi, and we can complete the diagram. This is r and we can extend it and complete the surface element by putting the edge. So these are the pillars which are dr. So this is rho d phi, which is r sine theta d phi, and this is dr. So the surface element is dr into r sine theta d phi. The shape of the surface elements have been shown, and they are all curved surfaces, and the normals to them will be decided by the sense of traverse of the contour by right hand screw rule. So the surface elements are curved surface elements, which are dr into r d theta, which is this one, which is this one, which is this one, and we can attach an end cap to each of them. In cylindrical polar coordinate system, which is rho phi z system, the length elements are d rho, rho d phi, and dz. Consider a point whose rho coordinate is this one. Now this is the x-axis, this is phi coordinate. So it suffers increment along rho, which is d rho, and if phi is increased by d phi, we have this portion which is rho d phi. So this is the area which we have constructed. It is d rho into rho d phi. That is product of these two length elements. We now take the product of these two length elements. So this is the arc element and dz is this portion. So this is dz. So this is the surface element that is generated. This is rho d phi and this length is dz. So we have rho d phi into dz and finally d rho into dz. So this is rho and this is z. So this is d rho and this is dz. So this is dz and this is d rho. So the surface element is simply d rho dz. So in cylindrical polar coordinate system, the surface elements are d rho rho d phi, rho d phi dz and d rho dz. In this system, the unit vectors corresponding to these area elements are very much evident. This surface lies in the xy plane, so we can take z hat to be the unit vector. We can multiply this with z hat. In this case, rho cap will be a unit vector which is normal to this area. So rho cap is the unit vector in this case, and in this case it will be phi hat because phi hat is perpendicular to the surface element. These are the line elements and there are three length elements in each coordinate system. It is clear that if we multiply these three lengths, then we end up with a volume. So with the help of these line elements or length elements, we can develop elemental volume, which we will do now. Next, the volume element. In Cartesian coordinate system, the length elements were dx, dy and dz. So this is dx, this is a dy, this is dx and this is dy, and let us put dz. So we have built the volume element with the help of this dz. So dv in Cartesian coordinate system is dx, dy and dz. In spherical polar coordinate system, the length elements are dr, r d theta and r sin theta d phi. We will multiply them and build a volume element which will develop in the diagram. This is r, this is theta, this is rho, this being the x-axis, this angle is phi. Now the increments. Theta increases to theta plus d theta and this arc length is traced, which is r d theta. Phi increases and this arc length is traced, which is rho d phi or r sin theta d phi. So let us complete the surface. Now we have to put dr at these four corners. So dr is simply extension of this r at 4 points. So this is dr at this point. So we have built a volume. Now these heights are dr. So we have dv which is equal to dr r d theta into r sin theta d phi. So it is r square dr sin theta d theta d phi, or you can put it as r square sin theta dr d theta d phi. In cylindrical polar coordinate system, the length elements are d rho, rho d phi and dz. And with the help of these three length elements, let us build a volume, an elemental volume. So this is rho, and this is phi, and this coordinate is z. Now phi can be incremented by a very small amount, say d phi, so that this point comes here and this is the arc element traced. Now let us attach d rho's at these 2 points. So this is d rho. This is rho d phi, and we have to put dz at these 4 corners. So we have built a volume element which is d rho d phi into dz. So it is a rho d phi dz.